All right, so we place these in line just like this. And what's the next step? What would you do next?
Yes, switch, sir.
All right, so let's place our switch here. And then what's the next step? The final step. Is current going to flow like this?
No, sir, you connect them.
All right, so we have to use more wires to connect them. So that's what we're doing now. Using more wires to connect our bulbs together. Now, is current going to flow now? Is current going to flow?
It can flow. I don't think that that's the correct way to flow it.
Why is it not going to flow? Hmm? Why is current not flowing?
One off over
Resistor.
in connect good, sir. We are stretch it on the left hand side, sir. That not connect good.
All right.
So
Yes, it's connected. It's connected properly. All right. Remember, it's a wire, so it can be moved. Right, but the connection is still there. What else? Look on your.
sir,
The
I'm talking right
resistor.
here, sir. Right here, I'm talking.
All right. Okay. So this is not connected properly.
Yes, sir.
All right. So this is our switch right here.
Yes, sir.
So if we connect our switch, right, we see that current begins to flow, right?
Yes, sir.
All right. We see the movement of current. Let's pause here. Let me add in our ammeter. We should have had that here. Okay. That's not what I wanted, but we might have to work with it. All right, so the ammeter is currently reading
How
what?
much current is
Exactly.
going?
So it is reading
Oh,
how much current or the electric current, essentially the flow of charge. Now, if we increase the voltage supply to the circuit by the battery, what will happen to the lights?
it brightens more,
Sir,
sir.
it get brighter.
Exactly. So the light brightens more. What happens to the current when we increase the voltage?
So the
Moves
It
fast.
goes higher.
amount of current start increase, sir.
All right, so the motor current starts to increase, and look on the electrons as well. These green things inside of it is called electrons. What happens to them when we increase the voltage?
It moves
Sir,
faster.
All right, so they essentially move faster. All right, so that is what we want to to achieve for this particular exercise. Now, what type of circuit is this? Is it a parallel circuit or a series circuit?
A series circuit, sir.
Right, so this is a series circuit, and how much path is there for current to flow?
Repeat, sir.
How much path is there for current to flow?
Once.
All right, so there's also one path for current to flow. So anybody not understanding so far, or anyone is lost? Is anyone lost? Everyone is okay?
yes, sir.
I believe Hector was here before, if I'm not mistaken. Yeah, I think Hector was here before. All right, Hector, you were here before, right? Hector,
Yes, sir.
you were here before?
No, sir.
Or you're just joining?
Yes, sir.
All right, so somebody left them. All right, no problem. Let's continue. All right, so like what Hector is here, right? So Hector, this is called a series circuit, right? And there is just one path for current to flow. If we increase the power supplied by the battery, what happens to the light sector? What happens to
Sir,
the light?
Sir,
huh?
it's spread wider, sir, and it get brighter.
All right, so if we increase the voltage, the lights will get brighter and essentially there will be more current in the circuit. All right, so move on now to the second aspect. All right, so we'll construct another circuit, but this time it will be a little different than the last one. So I'll just do that now quickly. So this one is a little different from the last one.
Sir, if I raise the voltage, sir, and it gets higher, sir, the heat will get more hotter, sir. What happened to the bulb glass, sir?
All right, so it depends on the type of bulb, right?
Glass,
Different bulbs, most bulbs are glass, right? You have some plastic bulbs, but most importantly is the amount of voltage it is able to withstand. So if it can withstand a lot of voltage, right? If the current gets too hot or the voltage is too much, then it can break or be destroyed or blown, right? So you really have to look out for um, the rating on your bulb. That's what you have to look out for. All right. Now tell me, how many paths of current is this now in all? How many
3,
paths of
sir.
current? All right, so
Three.
there are now 3 paths of current, right? Now, what happens if we disconnect one of the paths of current? Are the other 2 paths affected?
No.
No, sir.
Exactly. So there are 3 paths now for current to flow. And if we disconnect this particular section here, it will not have any effect on the other paths of current. So that's what we want to achieve. And what is the type of circuit? What is this type of circuit called?
A parallel circuit.
All right. So this is called a parallel circuit, right? On the other hand, this is called a what? What is this
Series.
called? A series circuit.
Series circuit.
All right. So that is it. All right. Let me go ahead and take a picture of these group members here. What is it for today? All right. So you may leave now. You can go. All right.
Is sir class done?
Yeah, basically. All right.
So
Brianna, or sorry, Eccleston, sorry. You may go. All right. Or I will have to move you. I'm not sure if you're at your computer or your phone. All right, so good morning. We'll wait a few more minutes for the others to join. Let's join us 2 persons here. All right, I'm waiting for at least two more persons, or even 3 persons can join the streaming persons. Let me pause the recording. So we will look hear me? Just indicates if you're hearing me. You can say yes sir, no sir.
Tomorrow to a safe house where she will finish her transition.
Science? Hello?
Yes, sir.
All right. Let's begin. All right. So when conducting or putting together an electric circuit, what's the first thing that we usually place inside the circuit?
sir. Is it rubber?
All right, you can use over here as your guide, right, to help. So what would you put in a circuit?
Sir, could you let the background black or another color other than white, please?
It's white on your screen?
Yes, sir.
Yeah, I can't change it, I'm sorry. I don't, I'm not able to change it.
Okay,
All right.
sir.
Yeah, so what would be the first thing that you would put in the circuit? You can use over here as a guide. Are you hearing me?
Sir, current.
No, not current. Right, the elements in the circuit. Right, so we have wires here, batteries, right? So let's put in our batteries first. All right, what could we put in next inside the circuit?
Sir, bulb.
All right, so we could place our bulbs there as well. So let's use 3 bulbs. Let's use 3 bulbs, 1, 2, 3. And what next can you put inside the circuit?
Sir, we would need a resistor.
All right, so we can omit the resistor. We'll use the light bulbs as our resistor. All right, what's next?
Sir, would need a switch to turn it on.
All right, so we would use a switch here. Let's place it here. And is our circuit completed? Is our circuit complete? What's next?
No, sir.
All right, so the other students can help, right? In this group, you can help as well. Campbell and Henry, you can also help. Is our circuit complete?
No, sir. It doesn't look like our circuit is complete. It needs wires to be attached, I think.
So you
to the
need
bulb.
wires to connect the various parts, right?
Yes. Yes, sir.
So we place a wire here. Let's extend this and place this here. And to connect our bulbs to the switch right here. And essentially do the same thing. So is our circuit complete now? Right, it looks much better. Is it complete now?
Yes, sir.
It's completed. Look on it again. We have our battery, we have our light bulbs, a switch, and our wires, but is the circuit complete? Now, do you have to connect all of these?
Yes, sir.
Yeah, so this is what is this called? An open circuit or a closed circuit? What is this called?
Closed circuit.
No, remember, it's open. Right? It's currently open. For it to be a closed circuit, all the sections have to be connected. All right, so we'll go ahead and close the circuit. And let's put an ammeter here. Right? Remember this? What is our ammeter used to do?
sir, measure current.
Exactly. So it's used to measure electric current. All right. Why is the current not flowing?
Because the switch is not on, sir.
Exactly. So the switch is not closed. All right. So the switch is now open and it's still an open circuit. If we close the switch, now we see that current begins to flow. And of course, our light bulbs begin to shine. Now tell me, what happens when we increase the voltage on our battery? What happens?
The bulbs shine
Sir,
brighter.
current
They produce more
increase.
light.
All right, so more light is produced. And what else?
The current increase.
All right, so there's an increase in current from here. And essentially that would be represent that there is an increase in the flow of charge in our wires and in other parts of the circuit. Now tell me, how many paths of current is this? How many paths of current is this? How many paths does current has to flow? Have to flow?
3 or so, sir.
So current has 3 paths to flow. Look over it
Sir,
again.
in this example you are talking, sir, are overall.
In this particular example, how many paths is there for current to flow?
One.
All right, so I hear something in the
Sir,
background.
7.
7? No. Think about it again. Right, current goes from the battery, right, to the switch and through our light bulbs and then back to the battery again. How many paths is that?
4.
No.
Sir, we not count the battery 2 times.
You wouldn't count the battery 2 times.
So it is 3.
It's not 3 either. How many paths is there? Is there another path for current to flow? Is there another section out here for current to flow? How many paths is there for current to flow? It would be 1, right? It would be 1, right? It would be just 1 path for current to flow. Yes or no?
Sir, we don't know how you get 1, sir.
Right. The reason why it's 1 is because you have 1 particular movement of current. So this is electrons. These green items here, or the green circles, represent the electrons, and they only have 1 path. Right? If there was another section here, right, then there would be 2 paths for current to flow. Right? There would be 2 paths. So you would find that current would also flow in this section here. So it could choose between this section or this section. Right? But because there's only 1 path here, let me remove this. There's only 1 way for current to flow. It doesn't have any other options. It only has to flow in this closed circuit. That's why it has 1 path. And what we call, what is a circuit that only has 1 path for current to flow? What is the name of that circuit? We spoke about this yesterday, right? Is it a parallel circuit or is it a series circuit?
Sir, I think it's a series circuit because normally parallel has to do with 2.
Exactly. So series circuit only has 1 path for current to flow. All right. So we'll move on to the next one. I will quickly bring this up. Right. We have our batteries. We connect them to our wires. this structure of the circuit might look a little different from the last one. All right. Go ahead and connect this here. Connect this one as well. Right, so we're designing this circuit a little bit different, and we have back our three bulbs. Let's place our 3 bulbs here. All right. Now, how many paths is there for current to flow now? Look at it carefully. How many paths is there for current to flow now? Hmm?
Sir.
Think about it. So over here, we had 1 path for current to flow, right? Current only had 1 option. How many options are there now for current to flow over here?
I think the more this I think the more
Sir, I think it's 4.
All right, so Heinz said 4, and Campbell, you were saying?
no, as I was saying, what was the question? Because I don't want to say that.
How many paths does current have to flow now in all? Or how many options are there for current to flow?
Oh, I think for all the light bulbs or just one?
For the circuit, for the circuit, how many paths of current is there? How many paths is there for current to flow? The entire circuit.
Oh, okay.
How many?
I think it's.
Just say it. You might be correct, you might be incorrect, but I'll correct you. Just say it. How many paths is there for current to flow?
Oh, I think it's 12.
12? No. Think about. Think about.
Sir, did a 4 or 5, sir. Because the last time, sir, when we go right round, sir, that I did only 1. And now we turn go inside. 4 of them go inside.
All right, so let's look on it.
So I must 5.
It goes from the battery, right? It goes from the battery. And then there's a path here, right? There's 1 path here. You see that? So it goes from the battery and then it turns off here, right? Yes or
Yes,
no?
sir.
All right.
Yes, sir.
All right, let's do it again. It goes from the battery and it passes here. And then it turns off here, right?
Yes, sir.
And then it comes back around.
Mm-hmm.
And let's do that one more time. It goes to the battery. It passes this section. It also passes this section. and then it goes down to this section down here and still manages to come back around. So how many paths of current is there for it to flow now? Want me to do that again?
Yes, sir. Do it again, please.
All right, so current leaves the battery and it goes to the first section here, right? And it turns off, right? So you have some of the electrons that are turning off. You can see them now. They're turning off. And they continue through the light bulb, causes the light bulb to shine, and then it goes back up to the output here, and then it combines with the other electrons and go back to the battery. Now we have other electrons that pass this section and then come down here and turn off as well. We can see the electrons that are turning off, and they essentially come back around here and combine with the others. And you have one more set of electrons that pass this section. They also pass this section, right? You can see them here. They're passing that section, and they come around, causes the light bulb to shine, and then combines with the other electrons. Now, how many paths is there for current to flow? How many paths is there?
2, 3, and then go back around. 4.
Right. So there are, in all, how many are there?
3.
Exactly.
I understand how you get.
All right, you understand now?
Yes, sir.
All right, anyone doesn't understand?
No, sir, me understand now, sir. Wait, it kind of make it sound like, say, when you return to your battery, sir, that actually count as one.
All right, so this is one path of current, right? It only has one option. While for a parallel circuit, it has more than one options or more than one path for current to flow. So that is essentially it, all right? Okay?
Yes, sir.
All right, I'll end this call. Let me send it in the group. So you may go.